A graph from standard form. So you can see we have y equals 2x squared plus 4x minus 1. And I have just a little xy plane over on the left. So the first thing we do when we're graphing from standard form is find our vertex. Our axis of symmetry, which can be found x equals negative b over 2a. The axis of symmetry is where the vertex is going to lie. So that's going to be our first step. So remember, in standard form, your a is always in front of your x squared, your b is in front of your x, and your c is all the way at the end. The c is useful because that does tell us our y-intercept. So we can put that on our graph if we would like, which it will end up on there, so I'll show you that again in a little bit. So we're going to plug in our b value, and we are going to switch it the sign, making it a negative. So in this case, it was a positive 4. So we're going to make it a negative 4 over 2 times our a value, which is 2. We're going to simplify that as far as we can. So in this case, it's going to be negative 4 over 4, which is equal to negative 1. So our axis of symmetry, or our AOS, is x equals negative 1. We now have our x of our vertex. So our vertex is going to be negative 1. And then we have to just figure out our y value. So an easy way to do that is just plug in to our equation. So we're going to replace all of our x values with negative 1. So we're going to have y equals 2 times negative 1 squared plus 4 times negative 1 minus another 1. A couple things: when you're plugging in a value for x, always put it in parentheses. So negative 1 squared would be negative 1 times negative 1, which is going to give us a positive 1. I'm just going to leave that there for a second. 4 times negative 1 is negative 4, and then minus 1. 2 times 1 is 2. 2 minus 4 is going to be negative 2, and negative 2 minus 1 is negative 3. Now you definitely do not have to write all of those steps, but just so you could see it, that is step by step. So you always square first because of your order of operations, then you multiply by the coefficient in front. So our vertex is negative 1, negative 3. From there, we can either make a t-chart and plug in some values on the left or the right of our vertex and then reflect them over our axis of symmetry. In our class, we've been doing, instead of doing that whole idea of points, we've been moving right 1, figuring out what 1 squared is since our parent function is x squared, and then timesing it by our a value. So again, that's the number of x moving from the vertex. And then our times our a value, which in this case, you can see up top, it is a 2. So 1 squared is 1, 1 times 2 is 2. We would do the same thing for right 2. So we would do 2 squared times 2. 2 squared is 4, 4 times 2 is 8. So I'm going to graph that, and then I'll show you if you want an XY t-table. So our vertex is negative 1, negative 3. We get over left 1, down 3. You can see my scale might be a little bit off. From there, we can move right 1 up 2. If we do it to the right, we can also do it to the left since our axis of symmetry is cutting down. So we would have right 1 up 2. Notice that this point here is also your y-intercept, which I talked about earlier, of your c value of negative 1. So you just want to make sure that matches up. It's an easy way to catch your mistake. Then from our vertex, we would go right 2 for this point over here. Sorry, you couldn't see where I was pointing. Right 2, so 1, 2, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. If you do it to the right, you can also do it to the left. And you can see we have our parabola. Remember, your parabola keeps going up. We could have done right 3 and done that also. Okay, now if you want a t-table instead of the right-left idea, All you would have to do is pick a couple x values to the right and then reflect them over, or you could go one to the right would be 0, another one to the right would be 1, and then you could go the opposite way also, -2 and -3. So if you plug those into your formula, the 0 is really easy to do. You should get xy points. So again, the first way, they are not points. That is just how you move from your vertex. It's using your transformation ideas. This is giving you points. You can also find this in the calculator by putting your equation into y equals and then hitting second graph. So you can see 2 times 0 squared is 0, 0 times 2 is 0, plus 4 times 0, which is also 0, 0 plus 0 minus 1 gives us a -1. If we plugged in 1, we would square 1, which is 1. 1 times 2 is 2. 4 times 1 is 4. Minus 1, so we'd have 2 plus 4 is 6. 6 minus 1 is 5. Plugging in -2, we would do 2 times -2 squared plus 4 times -2 minus 1. -2 squared is 4. 4 times 2 is 8. Plus 4 times -2 is -8 minus 1. The 8's are going to cancel each other out, leaving us with just -1. And then plugging in our -3. So we'd have -3 squared times 2 plus 4 times -3 minus 1. -3 squared is 9. 9 times 2 is 18. 4 times -3 is -12. Minus 1, so we'd have 18 minus 12, which would give us 6. And 6 minus 1 gives us our 5. Okay, so if we look at our chart, we should have 0, -1, which we do. We have 1, 5, 1, 2, 3, 4, 5. We have -2, -1, so we'd have 1, 2 over, down 1. And we have -3, 5 as well. So either way works. In our class, we've been doing the transformations. That's why we did the transformations to introduce this chapter. And it is a very quick and easy way. It also works with cubes, except they would not be reflected over. So you would do a couple on both sides. Okay. That is how to graph from standard form.